All right, here we go. It's another Monday. It is day 11 of quarantine for COVID-19. We are on AMI day 12. Hope everybody is doing good on this fourth week that we have been out of school. Can you believe we are starting our fourth week? Granted, 1 week was spring break, but I know several of y'all were messaging me over spring break because you're working on your AMI packets. Hopefully you've already got it started. If you are waiting to the last minute, I advise you to start them. You can go ahead and get them turned in, and the ones that you have finished into the filing cabinets that are in the front of the high school. There's one that's a turn-in filing cabinet, and there's another one that has AMI packets already printed out for you in the other filing cabinet. So today's work, you are going to need 5.1 gravity problems, and it looks just like this. It says 5.1 gravity problems at the very top. It even says day 12 over on the left-hand side. And if you read the intro piece of paper to this is all review, the stuff that we have already done. We just don't do a lot of worksheets in class, and what we do, I make them up. And so this is just extra work for you to practice, and it doesn't hurt to have this practice. So don't think, well, Miss Little, we've already learned this. This is back from October. Why are we doing this again? It never hurts to review yourself. You always need the review. Okay. If you do not have the availability to come up to the school, or you do not have the ability to print off the paper from the internet, go ahead and get a piece of paper. And at the very top right-hand corner, make sure that you write your name, class physical science, and the AMI day at the top right-hand corner. So this is AMI day 12. So you'd write your name, Joe Smith, below it physical science, AMI day 12. If you go even further and you're like, Miss Little, I don't have paper, but I do have internet access, and you want to do this on Google Docs. It's going to be a little difficult showing your work. I guess you can go into Google Docs and do the freehand drawing thing if you want to. If it means that you need to go that far, you can. Whatever you can do to get it done is what I would like to see. You're all resilient. I know y'all can do this. Need a writing utensil, and then also a calculator is imperative. There's a lot of multiplication and division, and if you can do this stuff in your head, more power to you, but please use a calculator. I need a calculator. Most of your phones have it. You've used it in class. Assignment today, read through the practice, which is the example problem at the top. If you still need extra help, you can go online to your 9th grade physical science book and read through pages 113 through 115. And then you're going to complete table 1, which is on the first page. You need this completed in order to answer the 4 required questions for today. And so you are going to complete numbers 1 through 4. There is a possibility for bonus, which is number 5. You are not required to number 5, but it's really cool to get to number 5. That is actually AP Physics work if you want to do number 5. All my GT students, I highly suggest you do. Okay, so this is the table that you see at the top. The table is the strength of gravity on planets in our solar system. So we're just looking and asking ourselves, compared to Earth's gravity, which we know that our gravity is 9.8 newtons per kilogram, we're going to look at what is Mercury's gravity compared to ours? What is Venus's compared to ours? What is Mars? What is Jupiter? We already know that Earth has a 1-to-1 ratio because we are Earth. They already gone ahead and give us the strength of gravity for each of these, and we're going to compare them to what Earth is. So the first one says Mercury is the first planet, and because it's the first planet from the sun, and it says its strength of gravity is 3.7. What is that compared to Earth's gravity? It tells us that it's 0.38, but I want to go through and show you why it is 0.38. So our gravity problem for today says compare the strength of gravity on the planets, and we're going to specifically look at Mercury, which is this little dude right here, the closest one to our sun. And so we're going to use the equation that 1 over Earth's gravitational strength equals x, which is what we're looking for, which is going to be the compared value over Mercury's strength. So I would set this up saying that 1 is where we're going to begin, if I can get a color, over, and Earth's gravitational strength we know is 9.8 newtons per kilogram, and it equals x. X is the variable that we're looking for. Remember, this is algebra. We're just looking at the variable of what we're looking for. So X is going to stand in. Then it asks me for Mercury's gravitational strength, and it's already told me what it is in the table, and it says that it is 3.7 newtons per kilogram. Well, now the next thing I have to figure out is I want to know what is X. Think back in your toolbox. Go back to your algebra, even 8th grade algebra. I think y'all do this in 8th grade algebra, or even in algebra 1. How can I solve for X? Well, if you said I'm going to cross multiply, you were 100% correct. So I'm going to cross multiply 1 times 3.7 and 9.8 times X. So I'm just going to rewrite that where I say that 1 times 3.7 newtons per kilogram equals X times 9.8 newtons per kilogram. X is our unknown. Let me put this little dot there because I don't want to confuse you with the X and your X. And I can say that that is just 3.7 newtons per kilogram, which equals X 9.8 newtons per kilogram. Well, I want X on its own. I don't want the 9.8 with X because I want X on its own. So in order to get rid of a number in the numerator, I need to divide it in the denominator. So if I divide this side by 9.8 newtons per kilogram, that means I can mark those out to say divide, but whatever you do to one side, you must do to the other side. So over here below 3.7, I'm going to divide 9.8, sticky, newtons per kilogram. So now I just have X by itself. And so 3.7 divided by 9.8 is 0.38, which equals X. And we're basically just saying that the results tell us that Mercury's gravitational strength is a little more than the third of Earth's. Or we can say the Mercury's gravitational strength is 38% as strong as Earth. So if you're a basketball player, and you're standing on Mercury, let's just put it in here, your gravitational pull, you're going to have 38% more, let's see if I can do a hoop here, more strength in your legs to make sure that ball gets in the hoop. So it's stronger. Okay, so I want you to do Venus on your own. Let's do one more example. So it already has 0.38. So let's do one more example, and let's look at, let's do Pluto, and let's do Pluto. We've already done the planets closest to the Earth. Let's do the planet farthest, ooh, I sounded southern, farthest away. So we're going to compare the strength of the gravity on the planet, so we're going to look at Pluto. So we know that we're taking 1 divided by our Earth's gravitational strength and equaling it to X, which is our unknown comparison. And we're going to look at Pluto. So I'm going to put Pluto here. So I already know that Earth's gravitational strength is 9.8 newtons per kilogram. And I don't know what Pluto's is, but it tells us its gravitational strength is 0.6 newtons per kilogram. So before I go, do you think it's going to be a stronger pull of gravity or a weaker pull of gravity? You can even compare that to Mercury. So let's look and see what it says. All right. So I know I have to cross multiply to solve for X. So now I'm going to say that 1 times 0.6 is 0.6 newtons per kilogram, which equals X times 9.8 newtons per kilogram. I've got to get X by itself. So I'm going to divide both sides by 9.8. These cross out because they're the same the numerator as the denominator, so we're basically saying it's 1. Now we're going to divide 0.6, and this is where I have to go get my calculator because I can't do that in my head. 0.6 divided by 9.8, and so we're saying that it is let's not do that color, 0.06% equals X. So So if I wanted to, I could multiply that by 100, and it's saying that it has a 6% comparison due to Earth. So let's go to our, ooh, that's not what I wanted. Go back to our, this is what I wanted. We said that it was a 0.6 strength of gravity, and so it had a 0.06 comparison to Earth's strength. So, does it have more or less? Has a lot less. Has a lot less. Okay, so now your job is to find for Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, and fill in the comparison. You have to do that in order to figure out questions 1, 2, 3, and 4. So let's do an example of how you're going to find the answer to questions 1, 2, 3, and 4. So the first question says, how much does it weigh on another planet? In these next 4 questions, you're going to be figuring out how much do each of these objects weigh. So in number 1, you're going to be looking at how much does a cat weigh on Neptune. Number 2, how much does a baby elephant weigh on Saturn? Number 3, how much would a baby weigh that was on Pluto? So you're going to flip-flop on this one. How much was it on Pluto, and how much is it going to weigh on Earth? And then the last one is, it says, imagine that it is possible to travel to each planet in our solar system after a space cruise. Use the list of those weights on each planet to figure out the order of the planets he visited. On Earth, he weighs 720 newtons. So you've got to figure out the list. So if he was at 655 newtons on one planet, what planet was that? 1,872 newtons on another planet, how much was that? 792, so on and so forth, until you figure out which planets he visited in which order. And he was 720 newtons on Earth. Okay, so this one asks, a bowling ball weighs 15 pounds on Earth. How much would this bowling ball weigh on Mercury? Don't be like, oh my gosh, I don't know how to do this. I just figured out all the other planets. You're basically going to use the same method, except for this time you're going to look at the weight on Earth compared to the weight on Mercury. And I'm going to put MER because Mars is with M also. And so I'm going to find that ratio. If I look back at my table, I know that the weight on Earth is 1 compared to 0.38, which is the weight on Mercury. So I'm going to take that ratio of 1 over 0.38, and I'm going to compare it to the pounds on Earth all over X. And X is my unknown. X is going to tell me how much it weighed on Mercury. Okay, so I'm going to go over to the side over here. And I know that in order to do this, it's the same way. I have to cross multiply. So I'm going to say that 1 times X, so I'm going to go over to this side. 1 times X is just X, which equals 15 pounds times 0.38. And because it's a comparison number, there's not really a unit. So I'm going to say 15 times 0.38. So X equals 5.7, and our only unit is pounds. So the bowling ball might weigh 15 pounds on Earth. Well, it weighs 5.7 pounds on Mercury. Make sure the first step you do on answering 1 through 4 is you find the ratio. You need to find the ratio first. So where we talk about number 1 for the cat, what's my next one? Oh, I shouldn't have done that. It's okay. So we look at number 1 for the cat. It says the cat weighs 8.5 pounds on Earth. How much would this cat weigh on Neptune? Well, I did not figure out the ratio for Neptune because I wanted to leave that up to you. But I know the first step I'm going to do, hopefully you've already gotten this written down on your paper, so I'm going to erase it real quick. Always go back if you need to and rewind. So I know that the first thing I'm going to look at is the weight on Earth, which weight is big W, little e, over the weight on Neptune. Once I find that ratio, remember the weight on Earth is always going to be 1. I don't know what it is on Neptune because I haven't found it. That's your job. Go back to the table and put it would be the ratio, the compared gravitational strength. So I'm going to put here for the compared of Neptune goes there. And then it's going to be 1 over whatever my compared ratio of Neptune was, which is going to equal the 8.5 pounds of the cat all over x, because x is what we're solving for. Then you're just going to cross multiply for number 1. Okay, not too terrible. On number 5, that is the bonus part. You are not required to answer the bonus, but it is fun. GT students, you know who you are. It would not hurt for you to go on ahead and try your best on that one. Just try your best. Ooh, look. All right, so your job is to complete numbers 1 through 4. For full credit, you must show your work. I don't know how you can do that on Google Docs. Some of y'all are smarter than me. You can figure it out. If you want to, make sure you share it with me. I can't see it unless you share it with me. Do number 5 for bonus points. If you do not have a calculator and you're like, Miss Little, these numbers, these exponents are so massively high. If you multiply exponents, remember you're just adding those together. If you divide exponents, you're subtracting those. I had a student message me over the weekend who started working on this, and after I finished it, I was like, oh my goodness, I feel so dumb. I forgot simple algebra 1. So, questions, email me, call me. Hope you all are doing okay. If you're not doing okay on this, please holler at me. I need to know. Have a great day. Talk to you later. Go clean your room. You know what? What's better? Vacuum your room today. Or sweep and mop it if you have hardwood floors. That would be good. Bye, guys.